Hi there, this video lecture is about isotopes, their similarities and differences, and the determination of relative atomic mass of elements by using natural abundance of their isotopes. Let us get started. Not all the atoms in a sample of hydrogen, for example, are identical. Some atoms of the same element can contain different numbers of neutrons. So, isotopes are defined as two or more atoms of the same element which differ in numbers of neutrons in their nuclei are called isotopes of that element. Now keep in mind that isotopes of an element have same proton number. They have same proton number, which is Z. Thus they have the same atomic number, and similarly they have same number of electrons revolving in their shells. For example, hydrogen element is a mixture of three different types of atoms regarding their mass numbers. Means hydrogen has three isotopes, which are simplest hydrogen, which is also called as protium or protium isotope of hydrogen. Second isotope of hydrogen is deuterium, and the third one is tritium. Now let us look at their isotopic symbols. Hydrogen or protium isotope is represented by 1H1, deuterium as 1H2, and tritium as 1H3. In case of hydrogen or protium, there is only one proton in the nucleus, since the atomic number of hydrogen is 1. But the nucleus of this isotope of hydrogen is without neutrons. It is the only atom in the chemical world which doesn't have any neutron in its nucleus. Deuterium has one proton and one neutron in its nucleus and with one electron like protium. Similarly, tritium also has one electron, one proton, but there are two neutrons sitting in the nucleus of tritium, which is the third isotope of hydrogen. Now let us see how the isotopes of hydrogen differ in number of neutrons. Protium isotope of hydrogen doesn't have any neutron in its nucleus, so the number of neutrons in the nucleus of protium is 0, whereas deuterium has one neutron in its nucleus and tritium has two neutrons in its nucleus. So up till now we have seen that all the three isotopes of hydrogen, they have same proton number, same number of electrons, but they are differing in number of neutrons in their nuclei. Now natural abundance of these isotopes in percentage is as protium isotope, that is the most abundant one, and 99.985% of hydrogen element consists of protium atoms or simple hydrogen atoms. Deuterium has got its percentage abundance as 0.015%, whereas tritium does not exist in nature and it is artificially prepared isotope of hydrogen. It is artificially prepared isotope of hydrogen. Let us take another example that involves the isotopes of carbon. Like hydrogen, carbon also has three isotopes, means carbon element. It is a mixture of three kinds of atoms regarding their mass numbers, and which are C12, C13 and C14, also written as carbon 12, carbon 13 and carbon 14 by putting a hyphen in between the symbol of carbon and mass number of the isotopes. Since their proton number is 6, therefore the number of protons in all these isotopes of carbon is 6. Number of electrons is also 6 in each case, because like atoms, isotopes are also neutral because they are also atoms but with the different mass numbers, whereas they differ in number of neutrons, and number of neutrons can be calculated by subtracting proton number from the mass number. So in carbon 12 there are 6 neutrons, in carbon 13 there are 7 neutrons, in carbon 14 there are 8 neutrons. So number of neutrons is different in all the three isotopes of carbon, Their natural abundance in percentage is as carbon 12 is the most stable isotope of carbon, and its natural abundance is 98.9%, whereas carbon 13 is 1.1%, whereas carbon 14 exists in nature in traces. Now let us see what is isotopic abundance, sometimes also called as natural abundance or percentage abundance. It is defined as the quantity of an isotope which occurs naturally relative to other isotopes of the element as percentage is called isotopic abundance. Stable isotopes have higher abundance. Whereas on the other hand, the unstable isotopes, which are sometimes also called as radioactive isotopes or radioisotopes simply, they have least percentage abundance. Radioisotopes, they spontaneously emit certain radiations which are called radioactive rays, and they can be alpha rays, beta rays, and gamma rays. They are unstable and have got a number of uses both in chemistry, industry, and in medical science. Isotopic abundance of an isotope is determined by an instrument called as mass spectrometer. It is determined by an instrument called mass spectrometer. Isotopic abundances of isotopes of an element can be employed to figure out the relative atomic mass of that element. Let us proceed further. Relative atomic mass can be defined as ratio of average mass of isotopes of an element to 1/12 of the mass of carbon 12 atom is called relative atomic mass. Relative atomic mass doesn't have any units, since this mass of an element is actually a compared mass. Therefore, it is a unitless quantity. So relative atomic mass, AR, is average mass of isotopes of element divided by 1/12 of mass of carbon 12 atom. Keep in mind that 1/12 of mass of carbon 12, that is equal to 1 atomic mass unit. It is a very tiny mass and is used to represent the atomic masses of elements and molecular masses. 1 atomic mass unit actually equals 1.661 times 10 to the raised power minus 27 kilograms. Very tiny mass indeed. Now let us see how to determine relative atomic mass of chlorine element. Chlorine has two isotopes, which are chlorine 35 and chlorine 37. Mass number of the isotopes of chlorine are 35 and 37 respectively. Their natural abundance as percentage is 75% and 25% respectively. It means that 75% of a chlorine element consists of chlorine 35 atoms, and 25% of this element is composed of chlorine 37 atoms. Now, in order to calculate the relative atomic mass of chlorine, we will proceed as mass number of one isotope 35 multiplied by percentage abundance, which is 75%, and 75% can be written as 75 divided by 100. The mass number of 37 multiplied by 25%, and 25% can be written as 25 divided by 100. On simplification, we get 35.5. So relative atomic mass of chlorine is 35.5. Now question arises, do isotopes have something similar, and how are they different from one another? The answer to this question is that isotopes have got some similarities in them, and they also differ in certain respects from one another. Now let us first see the similarities. Isotopes have a similar number of protons. They have similar number of electrons, similar atomic numbers, that is Z. They have a similar electronic configuration, and they have identical chemical properties, whereas isotopes have got certain differences and they differ in the following respects. First is number of neutrons. Isotopes have a different number of neutrons in their nuclei and they have different mass numbers, that's A. They have got different percentage abundances and have different physical properties such as density and rate of diffusion, etc. If you liked the video, please do subscribe my channel and hit the bell icon so that upcoming video lecture on chemistry may not be missed. Sharing is requested too. Thanks for watching.